Okay, we're just continuing on from question 3. We did question 3a at the end of the last video, where given 1 plus x to the power of 2n is this sum here to show this result, and we just substituted x is 1 to get that. In part B, we have to show that 2nc1 plus 2nc3 plus 2nc5 plus all of that equals 2 to the power of 2n minus 1. Now what you'll notice is you've got the 2nc1, you're missing the c2 term. You're missing the C3 term, but we know that, and also we've got, instead of like up here having 2 to the 2n, we've got 2 to the 2n minus 1. Where does that 2 to the 2n minus 1 come from? It's 2 to the 2n divided by 2. So what we're looking is for a double up of coefficients, like we did in one of those questions from question 2. So this is how questions will appear. They're not going to guide you. They're going to say, given that, show this, but you've got to recognise what may have, how you may get there, okay? So we've obviously got our part A result, okay? Now we need to see this part 2 result, okay? Let's look at our from part A. What I want to do from part A, I know part A is not written out completely, but I'd like to write it out in full form, okay? So from part A, we've got 2 to the power of 2n equals the sum from r equals 0 to 2n of 2ncr. I'd like to write that out in, expand it out at least up to the 5th term. That really is 2nc what? Remember, it's the sum of all terms from r is 0 to r is 2n. So isn't it c0 plus 2nc1 plus 2nc2? Do you get what I'm doing? Plus 2nc3, I'm going to keep going, c4 plus 2nc5, etc. plus, wouldn't this be all the way up to? Now notice they're asking to show that all of this 2nc, 2n minus 1, that's the second last term. So in my expansion, I'm going to go up, do the second last term and the last term. So the second last term, well, look, the last term is 2ncn, isn't it? So the second last term is 2nc to the n minus 1. Sorry. Dot, 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 dot. So this is what I've got. 2 to the 2n, starting from r is 0, r is 1, 2, 3, 4, 5, plus many dots in between, 2nc to the n minus 1 plus 2nc to the n. I'll just pause for a sec. Just going back to the very, I'll just keep that there, okay? But if we just go back to the, so this is this written out in full, expanded. But if we just go back to the original question, that 1 plus x to the power of n equals the sum from r is 0 to 2n of 2ncr x to the r. And if I actually write that out in full, okay, I will get 1 plus x to the 2n is from r is 0 to 2n. If I write that out expanded, okay, I get 2nc0 x to the 0, which is just 1, plus 2nc1x plus 2nc2x squared plus, now look at what we're trying to show, that 2nc1 plus 2nc3 plus 2nc5 all the way up to 2ncn c2n minus 1. So I want to have all these terms up to c5 in my expansion and the second last term and the last term of the expansion. So I've got that 1 plus x to the 2n is, sorry, I don't need the sum because I'm writing them all out. It's the sum of all these, which is 2nc0 plus 2nc1x, 2nc2x squared, plus 2nc2x cubed, plus 2nc4x to the 4, plus 2nc5x to the 5, plus, keep going. Second last term is 2nc to the 2n minus 1, plus the last term would be 2nc to the 2n. Okay, so that's that whole expansion. Sorry, you can't see part of it. That's that whole expansion written out. 1 plus x to the 2n equals all of that. Oh, yeah. Sorry, this is x to the 2n minus 1, and that's x to the 2n. Oh, geez, you can't read that. So, wait, I'll write them again. plus 2nc 2n minus 1 x to the 2n minus 1 plus 2nc 2n x to the 2n. That's what that says. Sorry, it's very messy. So basically it's from 2nc0 up to 2nc 2n x to the 2n. Right? Now, if we let or substitute x equals -1 into both sides, that is the only way that we're going to be able to double up on either the odd or the even terms. That's the only way you can do it. So if you substitute x is -1, you get 0 on the left, and on the other side we get 2nc0 minus 2nc1 plus 2nc2, because you get -1 squared is 1, minus 2nc3 plus 2nc4 minus 2nc5 plus dot plus 2nc to the 2n minus 1 x to the 2n, wait, that one must be the minus, because x to the 2n must be n is some whole number. X to an even power gives you a positive. So the last term is the positive one. So the second last one is the negative one. Does that make sense? Because it's x to the 2n. N is a whole number. So -1 to the power of a even number 2. 2n's even. -1 to the power of an even number is positive. So the last term is positive, the second last term will be negative. Now, oh, why don't I put the 1 in? I'm substituting, to make it quicker, I'm substituting x is -1, that will be negative. Oh, why don't I just substitute it up here?
No, you know the general form, isn't that a is power to n minus k?
Yeah, oh yeah, if it's a plus x to the, yeah, it's a to the n minus k. But in these cases, a is 1, but it's just 1 to the power of, yes, but that's a normal 1. It's with the other term, we're substituting x is -1. See, this is the expansion with the 1's already done. We still need to substitute now for x is -1. With all this type, you never worry about putting the 1's in the first expansion, because it's 1 to the power, because they're both positive. But see, now, once we've written that out, now we're substituting x is -1, which is why 1 is positive, 1 is negative, 1 is positive, 1 is negative. Now with this one, you just take all the negatives, because here we got 0 to the 2n, which is 0. So now we just take all the negative ones over, and now we get, so therefore 2nc1 plus 2nc3 plus 2nc5 plus all the way up to 2nc to the 2n minus 1 is equal to the positive ones, leave them on this side, 2nc0 plus 2nc2 plus 2nc4 plus all the way up to 2nc2n. So now we are able to make a substitution back into that. Sorry, I'm just a bit. So are we okay now? Now we can go back into this expression up here. And replace, actually no, not into that one, up into this one up here. We can go back into this now. You know how I had this? I can now say that 2nc1 plus 2nc3 plus 2nc5 plus 2nc to the 2n minus 1, sorry, is all of that other stuff. Or I substitute the other ones, actually. I want to substitute the other ones. So wouldn't I call this 1? I'll call that 1. So subbing into equation 1. Sorry, girls. You okay? Yeah, it's a bit tricky. So I know I've jumped a bit all over the place too. See, what I did, I used that result from part 1. That's the result from part 1. But then I was stuck with what to do. So I came back to the original expansion, I wrote it all out, and see, in part 1 we substituted x is 1 to get that result. But I needed to do some other substitution. I needed only to keep every second and double up. And the only way to do that is to start with the original expansion, write it out again, and substitute x is -1 and take all the negative ones to the other side. And now we can see that the evens are equal to the sum of the odds. Sum of the evens equals sum of the odd terms. So, because I'm trying to prove this result here, that where you're just adding up odds, do you see that? I need to substitute into the evens. So substituting that into 1, I'm going to substitute the evens. So what I'm going to do, so from 1, this is what I've got for 1, and I'll write it again. So this is what I've got for 1. I already know that 2 to the 2n is 2nc0 plus 2nc1. I'm just going to write it again, plus 2nc2 plus 2nc3 plus 2nc4 plus 2nc5 plus 2nc to the 2n minus 1 plus 2nc to the 2n. I already had that. That was my equation 1 at the top. Now what I'm going to do with that is group them, which is 2nc0 plus 2nc2 plus 2nc4 plus 2nc to the 2n plus, so I'm grouping them into evens and odds. Do you see what I've done? So what I've done, yes, I had this result, but I've noticed I only want to keep the odd ones. So I've grouped it into the evens plus the odds. Now going back to what I just did, I know that, so I'll call this equation 1, again, same thing. I want to substitute that the sum of the evens equals the sum of the odd ones in there. So therefore that is 2 lots of 2nc1 plus 2nc3 plus 2nc5. Do you get why I've done that? Plus 2nc to the 2n minus 1. Because I've substituted that 2nc0 plus 2nc2 plus 2nc4 plus 2ncn equals the 2nc1s. So those become the same as that. So I've got 2 lots of the second type. And on the left-hand side, I've got 2 to the 2n. Now all I need to do is divide by 2. So 2 to the 2n divided by 2 equals 2nc1 plus 2nc3 plus 2nc5 plus 2nc to the 2n minus 1, which happens to be 2 to the 2n minus 1, equals all of that. Hey girls, this is question 3C, and question 3C does guide you. It says, by differentiating, show that. But in a HSC question, let's say last part, they may not say, by differentiating, show that. But you've got to know, you've got to be able to look at the original thing that you've been given, and then look at this, and say, well, how do I get from there to there? Now, left-hand side, the fact that you started with an R is 0 to a 2n shows that you've now missed the first term when you're now going from R is 1 to 2n. That gives you the hint that there's been differentiation. The other place that gives you the hint of differentiation is as follows. If you differentiate, just looking here, 1 plus x to the 2n, what do you get? 2n, 1 plus x to the 2n minus 1. See how there's an n out the front here? That is a hint that the 2n's been brought to the front and that you've had a 2n minus 1 and maybe there's been a division by 2 or something like that. The other thing is you've got 2 to the 2n. This gives you a hint on substitution. How are you going to get 2 to the 2n? Substitute x is 1. But when you do this type of question, you don't substitute first, you differentiate first. So if you notice that there is a change from R is 0 to a change of R is 1, there's a differentiation. Because when you differentiate the first constant, you lose the first term. The other thing is, see how you had a 2n, and now there seems to be an n in front. So the 2n must have been brought down. Write that out and lower this down by a power of 1. I know you can't see the power of 1 lowered, but then they must have divided by 2, and that's why you lost the 2 and the 2. Because you would have had 2n to the front over 2. So this is definitely a differentiation question. Even if, so yes, but 2n minus 1 means 2n over 2. And that should have been a 2n when you bring the 2n to the front. So the 2's would have cancelled. So this, in a few places, is showing us that, so what's happened here without spelling it out? So in a harder question, they won't spell it out. But you'll be able to tell from r is 0 to 2n, when the power jumps up like that, it's differentiation. The other thing is the n's been brought to the front. So it would have been 2n, 1 plus x to the 2n minus 1. But 2n minus 1 means 2 to the 2n divided by 2. That 2 that was out the front there would have gone with that. They've definitely differentiated, and then they've just substituted x is 1. So that's what we're doing. First, differentiate both sides. So differentiating both sides of the original one. What do we get? Now you want to write out, you might want to write it out first, unless you think you can. I mean, you can just differentiate this, but you've just got to be very, very careful that you know that you'll go to r is 1. I like to write it out and then bring it back. So I'll just write out what my thing is first. 1 plus x to the 2n, I'm going to differentiate in a sec, is 2nc0 plus 2nc1x plus 2nc2x squared plus ... You can do a third one, but don't worry. Plus 2nc to the 2n x to the 2n. That's your whole thing. Let's differentiate both sides. What do you get? 2n, 1 plus x to the 2n minus 1 equals. What happens with 2nc0? 0. 2nc1 becomes, 2nc1x becomes 2nc1. 2nc2x squared becomes 2nc2 times 2x plus, the last one becomes 2nc to the 2n, what? Differentiate x to the 2n. And 2n to the front. If that was x to the 7, you'd go 7x6. If it's x to the 2n comes to the front, x to the x to the 2n. 2n, c2n's a constant. If you differentiate x to the 2n, doesn't the 2n come to the front, whatever it is? Write the x down and decrease the power by 1. Okay? So differentiating both sides, I've got that. Now, I need to substitute x is 1. Don't worry about what we're at. I mean, we're trying to get this result up here, this one. We're a little bit away, but not too far away. Okay, we're going to get there. Substitute x is 1, we get 2n times 2 to the 2n minus 1 equals 2nc1 plus, if x is 2, just be careful here. I might throw in a third term. I think I need another one to see the pattern. See, this is 2 times 2. I want to put in 2nc3x cubed just to see what we get. Do you see what I'm saying? So I'm not sure of the pattern. So plus 2nc3, what would it be? 3x squared, wouldn't it? If I add another one in there. Now, what is that pattern? It's 2nc1. I've got 2nc2, 2x, plus, I'm just writing it again, 2nc3 times 3x squared plus 2nc2n, 2n, x to the 2n minus 1. Oh, it looks like, ooh, did I substitute x is 1? I didn't. I didn't substitute it properly. So what do I get here? What do I have to get rid of? 2. Sorry, guys. Okay. So when I substitute x is 1, I lose that. I get 2nc2 times 2. Here we go, it's okay. 2nc3 times 3. And 2nc2n, 1 to the 2n minus 1 will be just 2n times 1. Do you know what I mean? To the 2n minus 1 is just 1. What do we notice about that big number 3 and that? 2 and the 2. I can just stick it out the front. Isn't this, see how that's 2n? Isn't that 2n times 2 to the power of 2n divided by what? Oh, sorry guys. 2n times 2 to the power of 2n minus 1. Isn't it 2n times 2 to the power of 2n divided by 2? You see that? And guess what? Those 2's cancel and you've got n 2 to the power of 2n. Okay, over this side, I'm going to stick the coefficient. See how that's a little 2 and there's a 2? This is a little 3 and there's a 3. I'm going to write it equals 1 2nc1 plus 2 2nc2 plus 3 2nc3 plus, looks like I've got 2n 2nc2n. Can you see the pattern? So, and now writing that right-hand side as a summation pattern, just check, is it what they want you to have? It is. It's the sum from r is 1 to 2n of r to ncr. Wait, because in this question, they didn't call it k, they called it r. So they're saying show that sum from r is 1 to 2n of r to ncr. You do have that in that format. That is r to ncr. R to ncr. All the way from r is 1 to r is 2n. I'll just pause that. Okay, everyone, 3C, part 2. We've only got a small audience, but that's okay. This is for the video audience. So by differentiating both sides of the original identity, which is 1 plus x to the power of 2n, sum of terms from r is 0 to 2n, 2ncr x to the r, show this result. So they might not even tell you to differentiate both sides of that identity, but how would you know to differentiate? The original one was r is 0, your new one is r is 1. What do you think? We've got a negative 1 in here. Negative 1, the other r minus 1 here showing that this has decreased by a power. Looks like there might be a substitution of x is negative 1 somewhere as well. Remember, how do you get 0 on this side? Substitute x is negative 1. So to get all of that equals 0, 1 plus negative 1 is 0, 0 to the 2n is 0. Here I can see a negative 1 to the power of r minus 1, indicating there must have been a substitution of x is negative 1 here. The r minus 1 to me indicates this is 1 power less of x to the r. Again, differentiation. So two things tell me differentiation. The r minus 1 instead of to the power of r. The r equals 1 instead of the r equals 0. Something else tells me a negative 1 substitution. Negative 1 to the power of r minus 1 must be negative 1 substituted for x. Another thing tells me negative 1 substitution. 1 plus negative 1 is 0. So, differentiating both sides. Before you can differentiate both sides, we better write out the expanded form. 1 plus x to the 2n is 2nc0 plus 2nc1 x plus 2nc2x squared. From now on, we should do the third term, x cubed, 2nc3x cubed, plus all the way up to 2nc, 2n would be the last term, x to the 2n. So that is what 1 plus x to the 2n is. Now we differentiating, so differentiating both sides, we get, let's go. We good? Bring the 2n to the front. 1 plus x to the 2n minus 1 equals 2nc0. If you differentiate that, you get 0. 2nc1x, if you differentiate that, you get 2nc1. 2nc2, if you differentiate that, you get 2nc times 2x. 2nc2, sorry, times 2x. The next one, 2nc3x cubed, differentiate it, you get 2nc3, 3x squared, all up to the last term. If you differentiate that, you get 2nc2n, 2nx to the 2n minus 1. Because we're bringing the 2n down to the front. Remember, the 2nc2n is just a constant, which actually happens to be 1, but we don't write that yet. Okay? Now, we look at what we're going for, and we need a 0, 1 on one side. It looks like there's been a substitution of -1. So we sub x is -1, and the 2n stays. 1 plus -1 is 0 to the power of 2n minus 1. It's just going to be 0. And we've got 2nc1. Now, what are we going to do when we substitute -1 for the x? Isn't it just going to be minus 2 times 2nc2? So I'm writing it as minus 2 dot 2nc2. Then -1 squared is +1, so plus 3 times 2nc3 minus whatever plus. Last term actually will be, I think, negative, because if n is, say, something like a whole number, and it is, like 10, it'll be 20 minus 1, 19, -1 to the, it's a negative. The last term is negative. And it'll just be 2n, because you'll get -1 to the whatever. -1 to some odd power, because n is the whole number. So we've got that. On the left, we've got 0 equals 2nc1 minus 2 lots of 2nc2 plus 3 lots of 2nc3 minus plus whatever minus 2 lots, no, minus 2n. So I've got minus 2n times 2nc2n. See, it's a minus because this will be -1 to some odd power. So therefore, to me, let's just see, now this is what you do now. You go back up to the original and write this in terms of that and just make sure it looks right. Is it the sum from r is 1 to 2n? Yes, it is. Is it -1 to the r minus 1? Let's see. -1 to the 1 minus 1 is -1 to the 0 is 1. That's why the first term is positive. Look at the second term. -1 to the r minus 1. Now r is 2. -1 to the 2 minus 1. -1 to the 1 is -1. That's why that term is negative. So it is correct. It's -1 to the r minus 1, r times 2ncr. So what you do, you look at what they've got there, and you just check, does this fit into that? If I substitute r is 1 and r is 2, yes, it worked for me for the first two. Therefore, this summation is this. Because that r is the whole, no. The -1 to the r minus 1 is the rotation between plus, minus, plus, minus. That's that. That r is the 2 and the 3. Then you've got 2ncr, 2ncr. It's not r to the 2n, r is on its own. So times. So what you do once you get to that stage, you look at the question that they've given you and you see whether this fits in. If you substitute, and if it does, just write it. Okay? So that's the end of that one. Now, question 3D. It says, by integrating both sides of this identity, show this result. Now, sometimes it's not going to tell you by integrating, but let's look for the clues. You had x to the r, or a 2n. Look at the powers you've got. 2n plus 1 over 2n plus 1. That is a clear hint of integration, where you increase the power by 1 over the same thing. So this is integrating, and then you seem to have a 2 to the 2n plus 1. What do you think the substitution for x is? Look anywhere. How do you think I got 2 to the 2n plus 1? If you integrate this side, actually, have a look at this side. If you integrate this side, what do you get? 1 plus x to the 2n plus 1 over 2n plus 1. That is that. All right, we've got the minus 1 here. It must be coming from the other side. So I'm integrating and substituting x is what? If you integrate this, you get 1 plus x to the 2n plus 1 over 2n plus 1 times 1, which is the derivative, which is the coefficient of the x. So they must have integrated, and what do you think they've substituted for x? Yeah, because you got 2 to the 2n plus 1. So that's what we're doing. We're going to integrate and substitute for x. Okay, let's start. Let's expand the original identity. 1 plus x. Actually, you know what I don't mind with this one? I'm wondering if I should just integrate it as if, no, you can't. 1 plus x to the 2n, I'm just expanding it, is 2nc0 plus 2nc1 x plus 2nc2 x squared. I don't think I needed 2nc3 because I'm going to go plus 2nc2n x to the 2n. Now I'm going to integrate both sides. I'm going to put the k on either the left or right, just make a decision, just one of them will do. 1 plus x to the 2n plus 1 over 2n plus 1 times the coefficient of x, which is 1, plus k. I put it on the left. The k goes on the left or the right. What happens? 2nc0, what happens to that? Plus 2nc1 x squared on 2 plus 2nc2 x cubed on 3 plus all the way up to 2nc2n x to the 2n plus 1 over 2n plus 1. So that is the integration of that. Now we need to, when you integrate and get a k or a c, you need to work out what your k or c are. You substitute x is, yes, because it wipes out the right hand side. Substitute x is 0, and what do we get? 1 to the 2n plus 1, which is just 1. 1 over 2n plus 1 plus k equals 0. So therefore, k equals, see, because I got 1 to the 2n plus 1, which is just 1. I can put 1 to the 2n plus 1. So therefore, k is negative 1 over 2n plus 1. Good. Now, let's go and put that back into the equation and make a further substitution. And that's now continuing with this, where we've integrated both sides. We know what the constant of integration is. It's negative 1 over 2n plus 1. I'm going to substitute it back in. And I've got, therefore, 1 plus x to the power of 2n plus 1 over 2n plus 1 plus k, which is minus 1 over 2n plus 1. Notice I've got same denominator here, is equal to 2nc0 x plus 2nc1 x squared on 2 plus 2nc2 x cubed on 3 plus 2nc2n x to the 2n plus 1 over 2n plus 1. Now, we've got a common denominator here. Can you see that? So isn't it 1 plus x to the 2n plus 1 minus 1 over 2n plus 1 equals. I'd like to write that right-hand side as a summation now. Isn't it the sum of all terms? Let's look, this is the general term here. From what? R is 0 to 2n. You can't tell with the first one. So it's going to be 2n CR x to the, look here. Well, if that's 1, that's 1 plus 1. If that's 2, that's 2 plus 1. Yep, R plus 1 over R plus 1. So that's what I've got so far. Now, we're nearly there. Ooh. Okay, no, we're good. So now what do you think we substitute? if you look at what we're trying to find, we're trying to show, I'm going to go back up to what we're trying to show. Look, we've got on the left, look at this side, that's an equals. You just can't see my equal sign. That's an equals. We're trying to show that it equals 2 to the 2n plus 1 minus 1 over 2n plus 1. I've got everything except here I've got 1 plus x. So therefore substitute x is 1. So now we substitute x is 1, and we ended up with 2 to the 2n plus 1 minus 1 over 2n plus 1. So that right-hand side, or our left, is correct. And it's the sum from r is 0 to 2n of 2n cr. Now we've got, remember we're substituting r is 1. We've got 1 to the r plus 1, which is just what? 1 to the r plus 1, which is just 1 over r plus 1. That right-hand side, so this is what I've got. 2, so substitute x is 1 into that. 2 to the 2n plus 1 minus 1 over 2n plus 1 equals 2n. Sum from r is 0 to 2n. 2n cr, 1 to the r plus 1 over r plus 1, which is just from r to 0, sum 2n cr, 1 over r plus 1, and it's proven. So girls, I don't think it's that bad. You either differentiate and substitute. So this is what we do. If the powers of x have gone down, and if the summation, instead of from 0 to n, it's gone from 1 to n, you differentiate and substitute values such as 1 or negative 1. If the powers of n have increased, and you see n plus 1s all over the place, you've integrated, you have to substitute x is 0 to find the constant, and then you substitute back in. You put k back in and then substitute another value, quite often 1. Okay? So I'll just stop. So by integrating both sides of this identity again, here is another show that. Again, there is a hint of the integration. Like if you look here, you can see what's been, like look at the right hand side. If you integrate, what do you get? 1 plus x to the 2n plus 1 over 2n plus 1. But then over here, we seem to have 1. There may be there could be a substitution of 0, or if you look over this negative 1 to the r, there could be a substitution of negative 1. So I think we've got a 0 substitution and a negative 1 substitution. Maybe the 0 substitution happens with the k, and the negative 1 substitution happens afterwards. All right, let's start. 1 plus x to the 2n, let's just write it out in full and then integrate it, is 2nc0. I think we're getting better at writing these out. 2nc1x plus 2nc2x squared all the way up to 2nc2n x to the 2n. Integrating both sides. Actually, didn't we work this all out before? So can we just go, or we'll practice it. Integrating both sides, we get 1 plus x to the 2n plus 1 over 2n plus 1 times 1 plus the constant equals 2nc0x plus 2nc1x squared. Sorry, that should be a little one. Plus 2n, that's a little one. Plus 2nc2x, sorry, isn't that x squared on 2? 2nc2x cubed on 3, all the way up to 2nc2n x to the 2n plus 1 over 2n plus 1. We have to work out the constant of integration, so we're going to substitute x is 0 to wipe out the right-hand side, and we will get 1 to the 2n plus 1 over 2n plus 1 plus k equals 0. So therefore we get that k is 1 to the 2n plus 1 is just 1. So it's just going to be negative 1 over 2n plus 1. So therefore, writing out the integration thing again, 1 plus x to the 2n plus 1 over 2n plus 1 minus 1 over 2n plus 1 is equal to 2nc0x plus 2nc1x squared on 2 plus 2nc2x cubed on 3 plus 2nc 2n x to the 2n plus 1 over 2n plus 1. Now we're trying to get that result up there. If you have a look, there's got to be some substitution for x, and I can see a negative 1 to the r. We must be substituting x is negative 1. Because the other thing is we've only got a 1 over 2n plus 1 left here on this side, and if x is negative 1, this whole thing gets wiped out. So we're going to sub x is negative 1. And we're going to get 0 minus 1 over 2n plus 1 on the left, because you get 1 minus 1, which is 0 to the 2n plus 1. And on the right, when you substitute x is negative 1, is the first term positive or negative? So you get negative 2nc0. The second term will be, plus 2nc1 over 2, isn't it? Yeah, I'm just going to put over 2. The next one should be a negative if x is negative 1, minus 2nc2 over 3. Plus, plus. What about the last term, if x is negative 1? N, of course, is some whole number. It'll be negative because it'll be negative 1 to an odd number. So you get minus 2nc2n, and that's it, because over 2n plus 1. The negative 1, the negative comes from negative 1 to the power of some odd number. We'll make it a minus in front. So, having a look at where we're trying to go. I think we need to swap sides first. Don't you think, girls? Because see how that hasn't got a negative 1 on 2n plus 1, it's a positive. So let's swap sides. And we get positive 2nc0 minus 2nc1 over 2 plus 2nc2 over 3, I've got a minus 2nc2n over n plus 1. Oh yeah, that's a plus. Yes, you're right. Plus equals the positive 1 over 2n plus 1, because I've swapped sides of everything. Now let's just see if this fits the expression up there, and it should. So does it equal, I'm going to write that expression out. We're saying that that is equal to the sum from r is 0 to 2n, which we do have. The sum from r is 0 to 2n, and they're saying it's negative 1 to the r, 2nc r over r plus 1. Now let's just see if we've got that. So that's what I do. I do that, and let's just see, do we have 2nc r? Let's see, 2nc2 over 3. See, 2nc2 over 3 is 2ncr over, that would be 2 over 2 plus 1 is 3. That bit's correct. Now, if r is 2, negative 1 squared is the positive. So it's correct. If r is 1, we've got negative 1 to the 1 is negative, correct. 2nc1 over 1 plus 1 is 2. So that's what I do from there. Write down the question and just check that it's right, rather than trying to write it yourself. Equals 1 over 2n plus 1, and we're done. Okay, that's the end of that video. So there have been 2 extra videos that we've produced after the lesson today. I'm going to now set homework. I've decided that we are not, for this exam coming up, you'll notice that questions like in exercise 5, what are we doing, 5F, like question 4 and 5 and question 6, etc., that they're quite different. Same with question 7. We're not going to do these types in this exam. So the only things that you're going to be asked is the possible integration, differentiation with the substitutions. Okay, but for homework, you can try question 8. I believe you can do question 8. You've got to decide if you're differentiating or integrating or nothing. Sometimes you don't even differentiate or integrate. So with this one, it may be just a straight substitution. With part 2, you have to decide, are you differentiating or integrating? There are 2 hints. It looks like a differentiation. So I want you to do question 8A and 8B, but you don't have to check it showing N is 4 and 5. I want you to do, so all of question 8, do not worry about question 9, it's the other type. I think you can do question 10. So homework is question 8, question 10. You can't do the 11 type or the others. No. Now, we're also going to look at the textbook for homework. So apart from question 8 and 10 from Cambridge in exercise 5F or whatever it was, I want you to go to the textbook, exercise 10.5. Can you do question 8? Now, question 8 is really basic. It's just a straight substitution. You can see for the first one, the substitution is just x is 6. The second one is a very simple substitution. You should be able to work those out. So I want you to do question 6, question 7. Also, so questions, not 6 and 7. So from the textbook, sorry, I want you to do exercise 10.5, question 8, which is just a straight substitution. Question 9, question 10, more than likely, is a straight substitution. So questions 8, 9, 10, and I want you to do question 13, 14, 15. So from, this is what we're doing. We are doing, if we just, what did I say? Exercise 5, 10.5, questions 8, 9, 10, 13, 14, 15 from the textbook. Yeah. Yeah, I'll go to the thing. This is your homework. Textbook. Exercise 10.5, question 8, 9, 10, 13, 14, 15. And from Cambridge, it's question, exercise 5F, questions 8 and 10. Now, the other types of questions, which are on the worksheet, the Cambridge ones, we're not going to do that type. We're only going to do integration, differentiation, or straight substitution in this exam. We will do the rest after the exam. So binomial theorem is finished at the moment until after the exam.